This large and imposing piece of equipment is a HP8902A measuring receiver, and these are very accurate devices for measuring the specific the frequencies and power of RF devices. Now, I picked these up in I picked this one and another one over here up in a DoD auction. And when you buy stuff in a DoD auction, sometimes you get good stuff, sometimes you don't. It's been rejected, and if we have a look at the top here, why was it rejected? Let's pull it off, and you'll see that the tag says that it does not read the proper frequency. So, does that mean that there's something that I can fix on this that will make it work? Or does it mean that the receiver is hosed and I may be parting this out? I don't know. Let's take a bit more of a look, see if there's anything more interesting around it. No, there's just general crud. On the top here it has some little sheets in it that explain how to do certain operations. Let's see if the other one is there. You know, the controls mostly seem to just randomly sort of seem to be okay. Alright, let's plug this in. Let's see what happens. Okay, so now I have the unit set up. Let's turn it on. See that it's undergoing its self-test here. Turns on all the lights. And then hopefully, fingers crossed, it'll come up and it'll give me two little bars. Now those two little bars, just making sure, the two little bars means that input signal is not sensed. So what I should be able to do is to go up to my signal generator. Let's turn the RF off there. Let's set the input to that. And now it's set to 1 gigahertz, so if I turn the RF on, this should go to 4 bars, saying that it's setting up a measurement. And man, is it way the hell off. So my Roden Schwartz SME 03 signal generator is actually utilizing, I have a GPS disciplined oscillator here and setting up a 10 megahertz standard, and I've checked that counter, and it is a bang on 1 gigahertz there, and it's coming down here and saying 300 meg. So let's set a frequency. Let's try 500 megahertz. And here it's saying 499. Okay, interesting. It's 750 megahertz. Wow. So we clearly have something wrong. They weren't lying when they said this tag does not read proper frequency. So what might have to try and do is I'm supposed to be able to push the calibrate button. Aha, error 21. Okay, well, I went and took a little bit more reader manual of this, and error 21 really wasn't a useful error for me. What it was telling me was that I was using, error 21 is basically I was using a function which didn't apply at that point in time. So I went and started playing around a little bit more, because if you remember, the tag said that it couldn't read frequency, but it would read, you know, lower frequency. So at 500 it'd read it, at 750 it wouldn't, at a gigahertz it wouldn't. And so I started playing around to see where the changeover point was, and
was about 649 megahertz. Once I got to that sort of point, then it suddenly stopped working. And so I went and had a read of the manual, and you know, HP really does make excellent service guides. But it turns out that they called out the fact that how the system works is that it has a native voltage controlled oscillator that goes from 320 to 640-ish megahertz, and to read below 320, it basically divides the oscillator up to get the local oscillator frequency, and then to go above 640, it basically doubles it. So I was able to go in and check and look and see that, you know, stuff under 640 really does work. And if I type in, you know, and you can't see this off screen, but if I type in 100 on my my frequency or signal generator, I see 100 here, and it all works fine. But if I type in 1000 megahertz or 1 gigahertz, I get a reading of 332 megahertz. So clearly what's happening is there's something wrong with the local oscillator. So to fix that, HP says get out service sheet 15, and it explains how everything works. And so when you basically go through and look at service sheet 15, and hopefully that is all in, you can see that we get the high frequency VCO in, and then based on what value is, what frequency you are, range you are in, you're going to get a divider, one of the 8 divider bands come in and fire, or you're going to go to the voltage doubler, the frequency doubler, and then you'll get that low out. So what that's all been done in is being done in this board here. And let me see if I can zoom in so that you can get a better view of that. We might just move it across. This board here is the low frequency A19 low frequency divider and doubler board. And so what I have coming into this board is I have up here, this is the high frequency VCO input, and it comes from an item up here just in the corner. It's just off the screen, and that's the voltage controlled oscillator, and that's going to get me that 320 to 640 megahertz signal, and then that's going to come into here, and then this is going to get a divided output and come out on that end. So let's actually go in and start working through the troublesheet here, the service sheet. And in fact, what it tells you the first thing to do is to go and do the direct control. And we can see here that it's going to tell you to go do a direct control with these special control functions. And then what we're going to see is what frequency is actually going to come out of A19. So let me go hook that up, and then we'll start working through that frequency set. Okay, so I have this all set up now, and what you can see is I have these 2 cables here, and these 2 cables, if we come over here, are going to my 53131A counter and my 8657B signal generator. And what the service sheet says is that I should feed in a known signal to the A19 assembly, and then what I'm going to do is go and hit a bunch of special functions. You can see that down there on the front panel here, and you type in the number, and then you hit the special key down here, and that's going to drive this board to do a specific task. And in fact, it's going to take us through each of the dividers and then the doubler. And then what I can do is I can see what the frequency is that's coming out of here. So I have this set up coming into this, coming into the board, back again. We'll just take a look at the counter as I type in each of these functions. Okay, so the first number that I have plugged into the measuring receiver is 0.000, and what that gives me is basically no frequency out, and you can see that because we're not getting any count numbers at all on that. Now I have 512 meg set in my signal generator, and so now I'm just going to work my way up and go to 001, and as you can see I'm getting basically 2 megahertz, and we should go 2 megahertz, 4 megahertz, 8, 16, 32, 64, 128, 512 until we hit the doubler. And this is checking to see whether the divider circuits in here are working. So let's go through that. And 4 meg, yep. 8 meg, yep. 16, yep. 32, yep. 64, yep. Okay, and then, sorry, now I've got 007. Alright, 128. Now I need to change inputs because these channels are limited to 225 megahertz, but channel 3 up here will go up to 3 gig. So let's change that to 3 gig. We're getting our 128 there. Alright, so now let's go to 0.008, and I'm getting 256, and let's go to 0.009. I'm getting 512, that's exactly the signal that's pushed through. So now I can go in and see if the doubler works. Now let me see if I remember how to do this, because it's 00A, so 0000, and then I think it is shift 0, and if I push that, you'll see that I'm not getting any double frequency. So that's starting to indicate that maybe there is in fact a problem with specifically the doubler. So let's go take a look at the next step in the service sheet. Okay, so the next test basically has me do the same thing, but you look at my spectrum analyzer to see that I'm getting I'm getting close to 0 dBm out of the system, and you saw I had some adapters and stuff. So the fact that I'm getting close to 0 dBm on that 512 peak is actually pretty good. So let's work our way down now. 0.008 special, and the peak that we want to keep tracking is this guy up here. So we're going to see it move basically by half all the time. So let's do peak search, and then you can see 261 megahertz. I could zoom in a little bit, but for the purpose of this, 0.007. Next peak left, 131. You can see that basically 6, that we're getting pretty much that 0 thing all the way down. And if I go to 001, and you really can't see it because I set my frequency, start frequency at like 500 kilohertz, stop frequency at 4 megahertz, and there you'll see the peak search, and you'll see the marker, it's the 2 meg. I'm getting enough signal out of that, so the divider network is all working correctly. When I type in, let me hit preset again so we can see the whole thing, and when I type in 0.00A and hit it, you can see that I'm not getting the appropriate signal in there. So now I should check the VCO divided by 8 as the second check, but I'm going to skip that for the moment and just go straight into the doubler band check. And what we're going to do is key in some values that we should be able to watch on the spectrum analyzer and see the signals move back and forwards. Alright, so what I've done now is I've basically set up the 8902A so that the doubler band is set up, it's all turned on, the DACs are all connected into the high frequency VCO. And now when I vary the inputted signal from 320 to 650 megahertz, I should see on here that band that is the double band as it moves from 640 through to 1300. So what you can see is that I've got it set for 320 megahertz already, and you can't see any band. And if I just keep stepping that up, you'll see that they're really nothing coming through. So the doubler appears to be the culprit there. You know, this is now at 650. I'm supposed to see that. So there's only one more check that we're supposed to run, and we're supposed to see whether or not the output filter is working. But I'm pretty certain it's the doubler is the problem here rather than the output filter, and it's not really going to help us because each of those things are going to come back and they're going to show that there's a problem there. So let's pop this out and take a look at the actual circuit. Okay, so I went to the manual, I printed out the relevant sections. I have the serial prefix on mine is 2414A, so I don't need to look at any of the changes because they change above. But this is the board, so let's take a little look at it. You know, let's zoom in so that you can see the board a little better. And what we have here is basically this board, and you can see that it takes the VCO in at the top here, and then it's going to divide it and send it out. And so it gets on the bottom of the stuff here, it gets a set, let me see that, gets a set of digital signals that will tell the divider circuit here what to do. So if we have a look at, let me move that out to the side here for the moment, and we can have a look at some of the circuit here. Let's see if the start for this service sheet. And so basically, you know, we're going to get come in here, we're going to get our device, and they're going to go into U9, A, B, C, and D. So let's see where those are on the actual board. So there's U9. So if you look at it, you know, this is going to start the divider circuit, and that's going to then feed into the actual gates that will do the division. And so here, if we look at this sheet here, this is going to show us the typical divider. This is divider 1 and 2, so this will give us anything in the band from 160 megahertz to 330. This gives us from 80 to 160. And then here's our doubler input filter. So we're going to take our VCO signal in, filter it, and then hand it off to the doubler. This is not particularly useful, so let's actually go in and have a look at the more of the full circuit here. And so basically you can see, if let's zoom in, and I'll move the pages around so that you can have a little bit of a better view of it. You know, we're basically going to get our motherboard signals are going to come in over here, and then they're going to come in and hit the bus that will then go and turn on the various dividers. And so out of here, effectively, once we work out what is going to fire, we're going to get a divider signal. Now, the divider signal, if we look over here, we can see it's coming off service sheet 17B. Now, I did print that out. Let me go find that. Okay, so here we are. So here you can see this is where the signals are coming in from the motherboard, and they're going into this encoder decoder here. And now these are two ECL logic encoder decoders, and you can, sorry, let me get that better in shot. These two decoders here, basically they take in, we get 4 data lines in, and they use that to pick which band. And so if we come up here and have a look, you'll see all of the higher order bands come from this encoder, and then all the lower order bands come from this encoder. And so if we look and see there are U15, I think, so that's going to be this guy here. So these signals are going to come up here from the board, and you can see them going into U15 here. That's going to then go and handle that. Now, we went through, and as you saw, those lower order ones worked. So the signals that are picking up the doubler band, and here you can see this is the doubler high signal. So this is going to come in, and there's going to be a set of like values, and effectively from those 4 points, we're going to end up switching some of these bands on at the same time as we're switching some of these on. So how they deal with that is that this chip has an input filter, or an input driver that will drive all of its values low or high. And so what they've done is they've hooked that into one of the lines here. So when these things would, when this other chip would generally trigger a band here, this band bit that's set here is also driving this to 0. So we've got some clean signals coming out. So if we trace this doubler signal around, we'll see that it basically flows through here, and it flows in to another level converter, and this is going to convert, flows through here and then into another level converter, and this converter is going to convert from ECL back to TTL. I don't know why they did ECL to TTL stuff. I'm assuming that just the age of the instrument, some of the componentry they wanted simply wasn't available in a TTL format, or maybe they had existing. A lot of the stuff in this system has been shared between older instruments, so maybe that's just some leftover stuff. Anyway, when you come in here with that doubler value turned on, we're going to turn on and trigger pins 6 and 7 here, and that's effectively going to turn on Q1 and Q2 over here, and it's also going to turn on these two transistors up here, and these transistors are in a transistor array. But effectively what it's going to do is it's going to turn on the doubler drive, and that's here. Well, man, I'm doing a horrible job of showing this. It's going to come in and it's going to turn on these transistors here, which is effectively going to turn on this guy here, and this is going to take us back to our sheet over here. So let me move that out of the way and come back to our sheet. And so you can see this is where that signal will come back in here, and it comes up and it hits this chip, this integrated circuit here, which is U4. And this is actually the frequency doubler. If you look, and if I zoom out a bit so you can see the entire sort of signal path, the signal path comes in through here and gets split into the dividers to get divided. And if from the output of the dividers, eventually it's going to come back in and come out over here. But when it goes to the doubler, it's going to come straight into this doubler chip here and go out into the output filters. So if I was to measure the values on these pins, I'd be able to measure the frequency coming in on pin 11 and see the frequency going out on pin 5 and see that that would be doubled. That would be possible if I had the extender board for this. And then we would be able to plug that in, and I would be able to get to the back here and do that. However, I'm pretty certain that the doubler is actually broken, and so I reached out to the Hewlett-Packard Agilent user group on Yahoo, and I happened to ask if anyone had a spare doubler, because these things are unobtainium now. You simply can't get them. And one of the members was kind enough to actually donate to me a board. So let me go get that board. Okay, and here we are. I've been waiting for this. Joe sent this up from Texas, and it took a little bit of time to get to me, but I'm pretty excited because I'm looking to get, hopefully, that one of the U4s on these boards will be working, and I'll be able to replace my board, my U4, my non-working U4, with one of these. So the bubble wrap is stuck together. Let's get them out. Did an awesome job packing them in non-conductive bags. Outstanding. Let me throw that out of the way here. And let's put on my little anti-static wristband. And let's take a look at the boards here. So this is a bad board that he's saying. So I'm guessing there's something wrong with the board completely. So this is my board here. Let's hit that over there. Am I zoomed all the way out? Let me zoom all the way out. So that's my board here. So these are the two boards that Joe sent. And if we go find the part number, my board part number here is 60024. And so this board is also a 6024. So this board should be an identical replacement for my board. This one is a 60126. So this is a later model board, and you can see some of the little differences in terms of how the components are laid out, the different selections. You know, here we have a TO38 can, whereas over here we have U3 being you know, a dip package. So what I'm going to go do is, the doubler chips still seem to be the same. So let me go and take the busted doubler out of here, and I'm going to start with the doubler from the bad board, and we'll see what happens. So to get these out, these are fairly simple. Let me get rid of the paperwork here so that we can see in. All they are, if you look, is just simply a little socket that's built in there. So if we just wiggle that very carefully back and forwards, that will actually pop out. Now fortunately, if you look, designers were good enough to put a little reminder as to where the little tab goes when you put that in. So let's go and wiggle this a bit. And now I'm hoping that there's some other reason that the board went bad here and not this particular chip. So we'll socket that back in. Let's make sure it's all in. Yep. Okay, now let's stick it back in my the 892A and see if it works. Okay, you'll have to forgive me. Because it's just a quick test to see if it works, I didn't want to actually hook up, get my camera stand in and everything. So now let's go and type in 750 and hit megahertz there and see. There you go. Let's try 1300. and it looks like that simple swap of U4 was all I needed to get the device working. So what I'm going to do now is just tighten up. I just hand tightened some of these. You actually should use a little torque wrench that's designed to provide the appropriate level of torque. I'm going to go tighten that up. We'll put the lid back on this thing, and then we'll start looking at what I need to do to run it through its operator checks to see that it's all working. Be back shortly. Okay, so I have the board back in there. Let's tighten up these items and some of the stuff that I moved to get in there. I'll put the screws back in and put the cover on and declare it a success, or at least run it through with some more tests. Let's get started. Alright, there we go. We're all back in. We're all tightened up. One of the things that you may have noticed while you were looking at this is this little guy here. This is a high stability time base. This unit came with the option for the high stability time base in it. And so I've already, while I was waiting for Joe to send me the doubler board so I could get the U4 chip, I already checked the high stability time base. The high stability time base here is bang on. I tweaked it a little bit. I have a GPS disciplined oscillator here, and I was able to get it to within 3 millihertz of my 10 megahertz signal, and then it bounced around in the 20 to 30 millihertz values underneath that. But effectively, it was bang on 10 megs, so that's a great high stability time base there. What I'm going to do is put the lid on this and then have a look at running it through the operator checks. We'll do that in another video. I hope you found this video interesting in terms of being able to find the problem and fix it with an 8920A measuring receiver. Catch you later. Bye.